thank you very much for taking your time after probably a hard work day for you to listen to, let's say, Romano and me today. This is one new kind of a format which we are going to do from time to time. It's called Expert Talks, and we will talk about different topics in software engineering. And today we will present two interesting topics. Romano will talk about how to use DevOps to build great products, and I will talk about high quality work in software engineering. And if you have any questions, please write down in the chat. After each presentation, we will take a few minutes to answer your questions. I see in the chat that you cannot hear us, no sound. Can you hear us, actually? Can someone confirm? Yes, okay, then it is not the issue on our side. Probably it's on your side. Yes, okay. Okay, so I will start with my presentation for today. Let's talk about what is high quality work in software engineering and what is not. And let me present myself first. I have, let's say, around 20 years of experience in different roles in software engineering industry, and I have also a research and industrial background. And my goal is to build great products and great teams. And also, I simplify complex topics through my writing, from where probably most of you know me, from LinkedIn and maybe some other networks and portals where I write from time to time. And I'm currently affiliated with 3MD as a CTO, and I write under the umbrella of Tech World with Milan on these networks. So let's start with today's topic and talk about what makes high quality engineering work. Is it Scrum? Some say we do Scrum, we are doing high quality work. Is this enough? Or maybe we need to do also clean code. We do Scrum, we do clean code. Is it high quality work? Maybe it's TDD. Some say you need to do TDD and then you are done, you are doing great job. Some say, no, it's not enough. You need to do also functional programming in order to do high quality work. However, I say there is no silver bullet, actually. There are some things you need to do, and I will talk later about this in this presentation. And I start with the first thing first. It is a team. You need to have a great team. And this starts from the hiring process. You need to hire people who have can-do attitude, who are proactive, who wants to learn, who are fast learners, who can receive feedback, and you provide to the team purpose and autonomy so that they can work and provide you great results and improve their skills. And when we talk about high quality engineering, I show you here some 5 pillars which I think are important in order to have that. That's customer centricity, proper software design, good code quality, some engineering principles or culture you need to have, and of course, quality first mindset. And all of these connected with fast feedback loops. And we will talk now about some of these pillars. Of course, we always start with the customer. The customer is someone who wants to build the product right. And this is, let's say, the goal of the customer, which we need to have in our mind all the time. And we as engineers, we want to build it in the right way. And usually our customer is not so much interested about our shiny architectures, clean code, frameworks, whatever. They want to have their problem solved. So this should be in our mind all the time. And we need to start with some kind of a plan and to work in some kind of, let's say, cadence to provide the value to customers. And how we can do this? We can use some kind of iterative deployment. I don't say here Scrum or Kanban or Safe, whatever, but you need to have some kind of iterative way that you should organize your team in order to have good way of working that will allow you to have early prototypes experimenting, and in the end to provide a value to your customer at the end of each of these cycles. When I say provide the value for the customer at the end of each cycle, it means that you need to provide actually working software to him. And how we can do this? We can do this by using this continuous deployment process, which means that you need to write a software and deploy it to production, or at least to some kind of a testing environment at the end of each cycle. But the question is how we can do this, because you need constantly to deploy something, but in the same time you are working on this. And in order to do this, you need to distinguish between deployments and releases. How we can do this distinguish? We can do reuse, for example, future flags, blue-green deployments, maybe some kind of permission systems. There are multiple ways how you can do this, so that you constantly work on some features, but in the same time you deploy working software to your customer every iteration. And when we start to work on some project, there is one thing that happens. It is called project paradox, which means that we need to make the most important decisions on the start, but our knowledge is at the lowest point, and this is the problem. And because we here need to decide, okay, which architecture we do, how we are going to organize ourselves, how we're going to, let's say, draw some conclusions. But the problem is that our knowledge is very bad. So these decisions could be very, very, let's say, weak. How we can fix this? We can fix this in two ways. We can improve our knowledge, which is hard because we are at the start of the project. So it's hard to let's say, pile up the knowledge so fast. The other possibility is to, let's say, lower these decisions. And how we can do this? We can do this by deferring decision until you reach the best time to make it help you to move forward with your business or in any direction which is possible. So we need to focus on value and not just output and deliver for our customers. So make this decisions late as much as possible to, let's say, continue with your project properly. And also what we see when we start with the project, we see how this Conways law always strike. It says that probably your software will much look like your organization. So if you have a big organization, you will probably create a big monolith, big enterprise monolith. And we don't want to do this. We want to properly architect things from the start. And for that, we need to do something which is called inverse Conway maneuver. And that means that we should create dev teams in order to encourage desired software architecture. So software architects, technology leaders should be involved in working out organizational structure from the start. And this will allow us to, let's say, go to the path of our desired architecture. How we can do this? For example, take a look at team topologies. There are some suggestions for you after presentation, what kind of variants you have and how you can do this properly. And at the start of the project, we need to do some kind of architecture or design. What I find out that architecture is overrated, but the simple design is very much underrated. I say that we should make things simple because clean design is like clean code. It's easy to read and easy to comprehend. And we should try to solve problems by trying and learning through them rather than picking some shiny architectural patterns and just employing them everywhere you can. And when I say simple design, I mean start with the document, some kind of a document, and employ a system design review and architectural design records. Ask your colleagues for feedbacks. Inside those documents, be explicit about trade-offs, because we want to produce such design that is testable based on our real business cases and designed for change. What this means, design for change? This means that we want to have a high separation of concerns and low coupling, because the quality of our system is defined by our ability to change it. And I always say start with the model or monolith if you don't have, let's say, any other strong reason, because model or monolith means that we divide the system into manageable models before assembling those models into a monolith for a single deployment. And we create separate models where each one can have its own architecture. And those models are pulled together into a single API gateway. This allows us later to pull out the separate models, maybe in some microservices if needed in the future. And while we develop, let's say, and start work on this, our software project, some things start to happen. And this thing that start to happen is called technical debt. We are starting to pile up technical debt. And as you see on this graphic, this is time axis. This is a time we need, which is available for new feature development. And this is time where we need to struggle with complexity and tech debt. And this time is actually shrinking. And this part is actually increasing all the time. And you then get some, after some time, you get some probably questions from your management who ask you why our development is so slow. And in the same time, I saw in a lot of companies lack of some process and strategies for managing technical debt and managing that complexity which arises from software projects. And also this technical debt impact very much developer happiness and job satisfaction. And when we talk about technical debt, there are different types of technical debt. We have bad code quality. We have lack of tests, high coupled code, unused features. You have features who are hanging around, out-of-date libraries, which probably cannot be updated anymore, bad tooling, or also out-of-date tooling, a lot of manual processes. You don't have automation. And also lack of knowledge sharing, which I also find very, very much in different companies. And the question is how we can fight this technical debt. First thing first is we need to be transparent about it, because code is some kind of abstract concept. People from product or from management, they don't know what is happening beneath. They're just seeing some UI applications. We need to say, okay, we have issues which are piling up. We need to work on them. On the other side, management and product need to empower the team to fix those problems and resolve the issues in a way that ideally we have a culture where you don't need to ask for a permission to do these changes, to refactor and to improve things. This will make us lower, probably 10 to 20%, but we will get it all back in the long run. Later, we will be much, much faster. What you can also do, you can try tech debt as a feature. So you move technical debt stories as a features on your boards, or special task forces, for example, a few developers work on something for a few days. Or you can try also with tech debt retros, where you create a retro, discuss your issues, and come up with the action points that you can, let's say, implement later in the next iterations. And one of the most important things I mentioned is a bad code, which is an important factor of tech debt, which we can see all around. And the thing is that code is very, very important concept which we need to fix in all of this process. And if we ask ourselves what is actually bad code, it is hard to understand first. It's not simple. It is confusing, probably messy. No one cares about it, and it's really scary. You probably all see some kind of bad code in your professional life. The question is why we write bad code. There is one thing called broken window theory, and it's when you see building like this, if you hit it with another rock, nothing will happen. If you see a nice building and you hit it with a rock, probably someone will chase you or call the police. So small things makes a difference. And one small mess can just get bigger and bigger over time. And when you talk about the code, good code is like a joke, so you don't need to explain this. And this is one of the reasons why I don't like code comments. If the code is simple and understandable, you don't need code comments, except some special cases where you need it. What we can do here, how we can make this thing good. There is this rule coined by Uncle Bob Martin. It's called Boy Scout rule. So every day you open your file, you start something, make a little improvement, rename to a better variable name, refactor to give more meaning or extract some logic, write tests for some kind of part of code if there was not added earlier. So leave the campground cleaner than you find it. And this is really the best strategy you can do here. And when we talk about proper way of working, you also need to have a proper engineering culture in your organization. And what does it mean, proper engineering culture? This means it's ideal engineering culture is based on properly architecting and adding value for your customer. For example, if you are stuck for 15 minutes, you should be able to ask for help someone, especially if you are, let's say, junior or trainee. You need to have a place for education and training. I see a lot of companies are giving to their employees time and money to go and educate themselves, because yes, we learn mostly from the job, but you cannot learn everything on the job. You need to have some time outside the job to learn new stuff. Also, you should be able to have some kind of a job rotation, stretch roles. We want to have more, let's say, T-shaped developers, how it's commonly called, where we have people who has cross-discipline expertise, but also deep discipline expertise. So you know different parts of software development lifecycle, but you are expert in one field. For example, you are very strong at software architecture or security or backend development, I mean, whatever. Because T-shaped developers change discussion from who knows how to do this to what needs to be done. Also, we should have proper knowledge sharing sessions recorded and placed somewhere where everyone can take a look. Mentoring and coaching, also one important concept, especially if you are, let's say, younger colleague, that you have mentor or a buddy who will work with you and help you when you are stuck, or give you, let's say, instructions to which path you need to take in your professional life. And also, we should have a psychological safety so that we can do experiments and that we can fail also in these experiments. And this is, let's say, it should be okay for our company, because failure is possible, and this should be just a learning point for us, not the catastrophic event, of course. Also, here I will just briefly go through some important engineering practices that you need to have. Source control, Git, of course, you need to have a central place to place all of your code, documentation, and also some other artifacts. Proper tests. We say if you don't have tests, it doesn't work. Check the test pyramid. You need to have different kinds of tests applied and to have it in your project. So with some code coverage, for example, from 60 to 90%, you should not be bothered too much with that percentage, but let's say around that. Of course, zero bug policy. So write a test for every bug you find and then automate. Clean code, we should be able to write nicely structured code. We need to know to identify these code smells. Take a look at this site to identify these code smells and to find a way how to, let's say, fight with those code smells. And for that, we will need to understand also design patterns, which are good, which are not maybe so good, how to refactor our code. This is very, very strongly related to each other. How to do TDD, BDD. TDD is very, very important thinking technique, where you start with the end in your mindset. So you need to, let's say, this is the thing that you cannot learn so well. You need to practice this a lot. Also, all of these good principles, 𝗏𝗏𝗃, 𝗏𝗏𝗃, solid, to understand them very well, because they're really very, very important. Why you should not have the same thing on multiple places, and to know maybe where you need to break these rules also. Automate everything you can, code analysis, tests, whatever you can automate, do it. So we don't want to have manual process nowhere if possible. Of course, do pair and mob programming with your colleagues. This is probably the fastest way to do these continuous deployments, as I mentioned before. If you don't do this, then you need to do a proper code reviews to check all of your codes for let's say, all of your code for code smells and all of these things which we mentioned. And of course, you need to have proper documentation, ideally living documentation that you have in your code, which is close to your code, ideally in the same repo with your code, because this will help you much in the future, also with new people coming to the project. At the end, I want to also present some books and materials for you. Of course, clean code, clean architecture for Uncle Bob, refactoring for monolith Fowler, pragmatic programmer, very old book, but still very, very true and for today. Testing, software engineering, Google, a lot of good stuff. Accelerate and team topologies if you are interested in all of this DevOps and organizational stuff. Domain-driven design, art of readable code, of course, design patterns. All of these important, let's say, things are which I mentioned here are covered with these books. Of course, there's much more books, but let's start with something. And in the end, I want to say that we should don't just learn, because in order to be an expert in something or a great craftsman, it takes time, it takes experience, it takes a lot of trials and errors. So go learn, but also do and fail, and then again learn, do, fail. Just don't just learn, because this is some kind of a procrastination also. And thank you. That would be, let's say, my part of presentation.
Then welcome to my presentation about how to build great products with DevOps. But quickly, first to myself, my name is Romano, and I work for 20 years now for 𝗏𝗃𝗃𝗏𝗏. I joined 𝗏𝗃𝗃𝗃 directly after university as a junior software engineer, became then an expert software engineer, then a lead software architect, and then a consultant. And during that time, what was always at my heart is how can we build, how can we continuously deliver value to our customer? How can we build great products, and how can we automate things? And during that time, also the DevOps movement started. And when the whole DevOps movement started, I jumped right on top of that. I became one of the organizers of the DevOps Meetup Zurich, which is a monthly meetup which we have. And I also became one of the organizers of the DevOps Days Zurich, which is a yearly conference over 2 days. And because DevOps is one of my beloved topics, I also have my own YouTube channel, and I also post a lot on LinkedIn and also on Twitter. Nowadays, I work for different companies in different industries and doing DevOps transformations. But what is the challenge? What do I see when I'm in these companies? What I always recognize is that the business, they have great ideas. They are together with the clients, they have plans, they have ideas, and they write it down into Word documents, into Jira tickets, and then they throw it over the wall of confusion to the development team. The development team takes these great ideas, looks at it and say, well, if you want to have that, we can implement that, and they implement that. Then they throw it over the wall of confusion to the testing team. The testing team looks at that, looks at the requirements and say, it looks not the same, but yeah, we test something and it's green, and they throw it over the wall of confusion to the operation team. The operation team looks at that and says, whoa, how can we operate that? But somehow they manage to operate it, and then it goes to the customer. The customer says, what is that? The business says, what is that? It's not what we have ordered. And the problem behind that is the missing alignment. It is these walls of confusion that you can see there. And that's a huge problem, and it comes from the silo organization, but not only from that. In the past, we did a lot of projects. And first, we did these projects with the waterfall process. So we plan, test, develop, and so on and so on. And at the end, we delivered everything. Of course, the scope, budget, and time was fixed, but time and budget were never fixed. Most of the time, we used more. Then we thought, whoa, let's do Agile. Agile is much, much better. And we were doing projects Agile, which means time and budget is now fixed and the scope is variable, and we are delivering in small increments. But we are still doing projects, but we are building products for our customer. What is the problem with projects? The problem with project is that a project has a defined start and a defined end, a set of resources, and also a set of features that needs to be delivered. Usually you say, we need to deliver these 10 features. So it's about the output, maximizing the number of stuff that can be produced. Number of features, number of user stories, tasks, own code. But when we develop products, it's not about delivering 10 features. It's about understanding the real customer need, solving the problem of the customer, changing the behavior of the customer. That's what a product is all about. And this is an outcome view. So we need to go away from projects to products. And one way to do that is by using DevOps, because DevOps is a mindset and a culture and a set of technical practices which provides close communication, integration, automation, and collaboration among all the people in that value stream that you see that there. This is this infinity symbol. And when we talk about all of these people, then the term DevOps is not a good term, because it means development and operation. And there are some smart people out there which said, yeah, but security is also very, very, very important. Oh, add security. So now we have DevSecops, which is development, security, and operation. And then some other people said, yeah, but business is more important. Then we had DevOps, which is business, development, and operation. But as said, it is very important to have all the people aligned here, and all the people need to join here. And so we could also have a term like devsecops-𝗫𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗀𝗃𝗃𝗀𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃𝗃 or we can just call it DevOps, because DevOps is about bringing all the people, process, and technology together to continuously deliver value. That's what DevOps is all about. And before, Milan explained you some techniques. And when you look at this infinity symbol, you see all of these techniques, because when you want to build great products, you need to use modern software development, which is DevOps. As you can see, we need to have agile requirements engineering and an agile backlog. We need agile software engineering practices, as Milan just explained. Everything should go into version control. We need continuous integration, which we will have a look at later. We need build and test automation. Also, security needs to be built in directly. Also, the test data management is needed, and we need a staging environment, which is a production near environment where we can test our software. And of course, we need to automatically deploy. And then we need canary releases. So releasing small sets of functionality to a small set of users with feature toggles and dark launches. And if something happens, we want to have that cross-team collaboration. And for that, we need to have proactive detection. We need to find the bugs before our customers see them. And for that, we need to have a full stack telemetry where we see all of the problems, where we get alerts about the problems, where we also can measure the features if they are really used, so that we have the insights, so that we can feed again the agile requirements engineering. This is what modern software development is all about, where DevOps helps us. So, but how do we get away from these projects to these products? So first of all, we need to apply whole system thinking. We need to think in that whole value stream. And therefore, we need to identify this value stream. How do we do that? With value stream mapping. We take all the people that are within this value stream and we give them Post-its. We bring them into a room and then we say, okay, now what are the steps which are needed to bring an idea into production? And we put them on the wall. Here you can see feature definition, design, code, test, and so on and so on. Then we say, okay, who is involved in that, or who is the owner or needs to do something? Here, product owner, architect, developer, tester, and so on. And then we say, okay, now we have a clear picture about the whole process. We see the process. And already this is quite outstanding because many people have not seen the whole process. So after that, we want to identify the bottlenecks. And for that, we have the process time, the lead time, and the percentage completion accuracy. The lead time is the time it takes from the end of a process until the end of the other process. So when we look at testing, it's from code end until test end, and it's 336 hours. When we talk about the process time, this is the time where we are really doing actual value adding work, where we are really testing. This is 8 hours. So we already see now, there are a lot of waiting time in there. So this could be a bottleneck, which we need to address. The percentage completion accuracy is a number which tells us in how much percentage the next step can use the result of the previous step as is. So when we look at code, it's 60%. So in 40% of the cases from test, we are going back to code. So maybe the coding is not so good, and maybe we need to change that. So when we now look at this value stream, then we already can see that we can automate quite a lot of things in there. And this is where we are building up a continuous delivery pipeline. And for that, we need to clarify a few terms. First of all, the continuous integration, CI. You may have heard of the term CI/CD. Many people are talking about that. But now let's concentrate on CI. So when we have the continuous integration, then the developer is writing code on his local machine and commits the code to the source code repository. There, his code gets reintegrated with the rest of the code. This is why we call that a continuous integration. And for that, we have a continuous integration server. We build the code, we do the code analysis, as Milan pointed that out, do the static code security analysis, we do the unit testing and the integration testing. And the most important thing is that we get as fast as possible feedback back to the developer, not within hours, within minutes must be that feedback. So the output of the continuous integration is a deployable artifact. And with this deployable artifact, we are going into continuous delivery, because with continuous delivery, we are doing continuous integration. We get the deployable artifact, and then we automatically deploy that into a staging environment, into a production year environment. And we give, again, fast feedback back to the developer. here we then can execute automated tests or manual tests. Now, when we are doing continuous deployment, then we are doing continuous integration. We are doing the deployment into the staging environment, but then we execute a set of fully automated tests so that we can ensure that everything is okay. And if they are green, then it goes directly into production, will be deployed. And again, a set of tests will be executed to assure that everything is okay. And we give fast feedback to the developer. And if it fails, then we do an automatically rollback. So that's continuous deployment. Most of the time you will hear that people are doing continuous integration and continuous deployment, but they don't. They just do continuous integration and continuous delivery, which is completely okay because continuous deployment is quite a hard thing to achieve. Now, when we look at such a pipeline, then this is just an example of such a pipeline, so such a CI/CD pipeline. You see there is a lot of tools in there which you can use. And when we look at that, then we also see that when we talk about the continuous delivery pipeline, then we have in the beginning continuous exploration and in the end the release on demand. And there is even more tools in there. So now, of course, there are vendors out there which say, well, we can cover everything. You see that we are very good. When you take a closer look to that, then you will see, yes, sort of. You need to replace quite a lot of stuff, but of course, there are some nice integration points. So they deliver that. That's quite a good thing. But when we now look at this continuous delivery pipeline, then this is nothing else than the conveyor belt that we have in our digital factory. Because what we want to do is we want to deliver standardized our software. So we want to bake in the quality right from the beginning. We want to have as much automated as possible so that we can continuously and fast deliver value to our customer. And when you look at that, this is nothing else than platform engineering, and which enables you to do DevOps in the end. So platform engineering provides you the platform where you are building up the great products on top of it. So looking at that continuous delivery pipeline, as said, we want to bake in quality right from the beginning. And for that, we need to understand that baking in quality is about continuous feedback. When we look at the projects, there we have the traditional V model. We have delayed feedback. Why? Because a BA will write a feature. Then a little bit later, another BA will write a story about that feature. Then a developer will write code on that user story. Then, if we are lucky, he or she will write some tests. If you're not lucky, he or she needs to deliver 10 features and cannot write the tests. So the testing of the story will be done by a QA sometimes later. And then the whole feature will be tested by another QA sometimes later. It can easily be that between writing the feature and testing the feature, there are 3 months, 6 months, a year. What we want to do is we want to shift left. How do we do that? We do that by applying behavior-driven development. This is a form where we set the acceptance criteria in the given when-then form. This allows us to have very clear acceptance criteria, which we then also can use for our stories, which we then can use for our code, because with these acceptance criteria, we can put them into the code, directly into the code, and generate tests out of that. This is test-driven development. Or if we have bugs or any features and we don't have BDD, then it is always a good thing to use test-driven development, as Milan explained that, because with that, we get tests directly, and the tests are executed as fast as possible, which is that shift left. And with that, we are getting fast feedback. Now, when you again look at the test pyramid, then traditional project-oriented test pyramid was about finding all of the bugs. All of the bugs need to be found. So you had a huge amount of end-to-end tests, which were slow and expensive. You had some integration tests and only a few unit tests. Nowadays, with agile development and the agile testing pyramid, we want to prevent bugs. It's about a risk-based approach. So we get a lot of unit tests, some integration tests, and only a few end-to-end tests. So again, when we look at the DevOps cycle or the infinity symbol, we can clearly see that when we are planning, we need to apply behavior-driven development. We need to have a clear definition of ready when a feature or a story is ready. And when we are going to code, then we need to apply the test-driven development approach, where we have the test-first mindset, where we always first write the test. Then in the build, we execute the unit test and also the static code analysis. And we also need to have a clear definition of done when something is really done. This is how we build in quality. But it does not stop with that, because we also need to build for operability. And this is very important thing, because you may have heard the term, you build it, you run it. This is sort of also a mindset where we are not throwing things over the wall of confusion and it's ops problem now. It's about thinking about how can we architect, design that system so that we can operate this system. So it's a lot about architecting for operability or designing the system for operability, which means that we have a monitoring system and that's a log messages that we can use for the alerting and also for the monitoring of these systems. And of course, we also need to practice disaster recovery. We need to have a notification strategy when something happens. And in the best case, we have automated everything and made it as operability as possible. But if something happens, then we don't want to blame ops. We want to have cross-team collaboration where we all work together. And when an incident happens, sorry for that, all good. And when an incident happens, then we want to do post-mortems. So we want to continuously learn and continuously getting better. And this means when we go again back to this infinity symbol, that when we are going to plan, we need to design and architect for operability. And when we are coding, then we need to build in the application telemetry so that we have the events and the data so that we can evaluate our software and build the alerting system. Also, everything needs to be code. Also, the infrastructure needs to be code. And with that, we then can continuously do the integration, test automation, staging, the canary releasing, the cross-team collaboration, and the full stack telemetry. And this is how we build great products, by going away from projects to products, because we don't want to focus on the output, we want to focus on the outcome. So the real user need, we want to solve the real problem and not just implement 10 features because of the project. We also want to apply whole system thinking. You just saw that we have a value stream. We always have a value stream. And we need to identify that value stream, and we need to identify the bottlenecks directly in this value stream. And the whole value stream is nothing else than a continuous delivery pipeline where we can automate things. And by automating things, we need to build in quality right from the beginning so that we can ensure the quality and we need to architect for probability so that our products are really great products and the customers are happy with our products. This is how we build great products. Thank you very much.